Okay, so in this video, we are looking at questions that involve a series of future values. So let's remind ourselves of what's in our log tables. Our compound interest formula, which is here on page 30. This is what we're familiar with. And of course, this gets f, the final value, in other words, a future value of p, a principal amount that's invested and where you are earning interest on it. And your F then gives you, as I said, the final value at the end of that investment. So a future value at the end of an investment. So up until now, when we've been dealing with this formula, we've just been looking at a certain amount that's invested and there's a compound interest on it. So you're earning a certain amount of interest over a certain time period, okay? What we're going to look at now are questions that involve not just one investment, but a regular installment of investments. So not that you're just maybe putting 1,000 euros in an account and leaving it there for 5 years, but perhaps you are doing a monthly saving of 50 euros over a 5-year period, but you are investing 50 euros every single month. Okay, so take a look at this example. Calculate the final value 1 month after the final payment of saving 50 euros every month over a 2-year period in an account which has an interest rate of 0.4% per month. Okay, now the first thing we have to look at, like I said in our previous lesson on rates, you always have to make sure your rates match. So you have to analyze your time frame and your rates and how much money you're saving, your investment, and make sure everything is the same time frame and that the rate is matching the time frame, etc. So what we have here is an installment every month, okay? We do have then a monthly rate, which is good. These two match, but it's over a 2-year period. So the only thing that doesn't match here is the 2 years, okay? So I'm going to need to consider in terms of months here, and 2 years in terms of months is 24 months. Okay, so now I have everything matching. I have my time frame in months, I have an installment every month, I have a monthly interest rate. Okay, so the next thing we need to consider now is, in my first installment, right, the very first 50 euros that I put into that savings account, that is going to be in the account for the full 24 months. That very first investment or installment of 50 euros will be in the savings account for the full 24 months, okay? So that 50 euros will earn 0.4% interest. So now the I that I fill in here, of course, has to be, remember, in decimal form. So 0.4% divide by 100, of course, will give you the decimal form. So that 50 euros will earn that 0.4% interest. So we will multiply by 1.004 to get that 0.4% and add it on. And of course, how many of those is there? As I said, that 50 euros is the first installment into the bank account, and therefore that's going to be in for the full time period. So that's going to be in the 24 months. So now when I come to my second month, I will pay another 50 euros into that account. That will also earn 0.04, in other words, 0.4%. But that second payment won't be in as long. That's only going to be in 23 months. Does that make sense? The very first 50 euros I pay into the savings account will be in for the full 2 years. Then the following month, I pay another 50 euros into the account, but that, of course, will only be in for 23 months. The next installment, of course, will be 22, and so on to the final 50 euro installment at the end of the 2-year period. That final installment will be in, because I want it at the 1 month after the final payment, so that last calculation will earn that 0.4% in that final month because we want the value at the end of the month. But that final payment will only be in, of course, for 1 month. It will be the last month's installment. So what I have here is a geometric series, actually. Now, technically, your first installment is in for the longest period of time, and then so on, it goes decreasing. But for looking at a geometric series, it's going to be easier for me to write this in ascending order. So I'm just going to rewrite that with the rate to the power of 1 first, and then consider all the way to the power of 24. So technically, I can rewrite this series as this. When I rewrite like this, I'm going to be able to work out what all of this adds up to by using the sum of a geometric series formula. And I'm going to take that down for myself here. That is, of course, in our log tables, page 22, for a geometric series. And it is a geometric series because I am multiplying by 1.004 each time. So we need to figure out what each of our pieces are for this formula. Your A is, of course, the first term, which is 50 times 1.004 to the power of 1, which is just 1.004. The common ratio, what you're multiplying by each time in that series, is, of course, 1.004. And n, the number of values, well, we have 24 terms altogether in this geometric series. So let's fill it in. Our A, 1 minus our rate to the power of 24, all over 1 minus and our rate, our common ratio, should I say, 1.004. Now let's do this on the calculator. All right, so get your fraction button up and just be very careful. There's a lot of brackets here, there's powers and everything to put in. So just be very, very careful of what you're doing. I'm going to type it in exactly the way I have it. Take your time. And we're getting 1,261 and 88 cent. So that is the final value of me doing a €50 saving every month over a 2-year period and earning 0.4% per month on each of those installments and investments. Okay, let's take a look at this question. So here we have a special savings account and it offers an AER of 4% per annum. If I invest €2,000 at the beginning of each year for 5 years into this account, how much will my investment be worth at the end of the 5th year? Okay, so the first thing, as I said before, you want to check your rates. So I have an AER, which is a 4% per annum. And I'm investing at the beginning of each year. So it's a yearly investment, so that matches. And the time frame is 5 years. Okay, super. I have a yearly rate. I am investing each year and it's over 5 years. So we are matching up totally there. So this is going to be another future values series question, okay? So we're starting with our €2,000 and it's going to earn 4%. All right, so we are multiplying by 1 and adding on 4%, put it in as a decimal, of course, 0.04. And I'm going to write it again in ascending order. We're going to have one installment, that can be the last one, and it's the end of the year, so we will earn interest on that last payment. And then this will be the second last one, and all the way up to our very first €2,000 investment will, of course, be in the longest. It'll be in for the full 5 years. So again, we're going to use our geometric series formula because we want to add all these terms up. So we want the sum of the series formula, and our A, of course, is equal to 2,000, 1.04. I'll just do the little addition there. to the power of 1. Our common ratio, we are multiplying by the 1.04 each time. And the number of terms is 5. So A, 1 minus the common ratio to the power of 5. Watch your brackets. 1 minus and the common ratio underneath, 1.04. Let's do this on the calculator. Fraction button. 2000, 1.04, open the bracket again. 1 minus 1.04 to the power of 5. And then come down 1 minus 1.04. Now, do practice this, okay? I know it's one thing looking at me typing it all in nice and quickly, but you need to make sure you can do that too. And your calculator work is a skill in and of itself. So do practice. So we are getting an answer of 11,265, and of course we'll round 2 decimal places always with money, and 95 cents. That's what that investment is going to be worth at the end of the 5th year. Okay, let's have a look at this question. Now, if you're feeling confident, why don't you press pause and see how you get on with this? Calculate the final value 1 month after the final payment of 36 monthly installments of €20 at an interest rate of 0.5% per month. What is the total interest earned on these savings? Okay, so we're going to check our rates. I have 36 monthly installments. I have a rate that's per month, so that's fine. And it's €20 per month. And there's 36 of them. So we've got the time frame of 36 months. We have a monthly installment of €20. We have a monthly rate of 0.5%. So we're all matching. So all is good rate-wise. So let's write out our series. So we have €20, 1 plus 0.5%, divide by 100, of course, to get the decimal form of that. So that last payment, that final installment is the one that's only in for 1 month. And then the second last one is in for 2 months, and all the way up to the very first installment, which is in for the full time frame of 36 months. And so get your formula written down for yourself and identify your A, R, and N. And filling in for your A, and we'll do this on the calculator. Check that you're getting the same answer as me. I'm getting 790, and again, 2 decimal places, so 66. Now, just be careful here. Always, a very good exam technique is our tip. As soon as you get to the end of what you think you've got to the end of the question, you've done your working out, go back and read the question again and double check you are actually giving the answer that they're looking for. Now here they're asked what's the total interest earned. This is the amount at the end in the account after that 36 monthly installments, after earning the interest on it. This is what you have at the end. But of course, the interest that you've earned, you must take away what you've put in, which is 36 of your €20 monthly installments, to see how much interest you've actually earned over the lifetime of this investment. So we're going to subtract the amount of money that we actually put into the account, which was the €20 a month over 36 months. And of course, that tells us exactly how much interest we did earn over the lifetime of the investment. So that is the actual answer to this question. So always watch out for that. Okay, let's have a look at this question. If a bank advertises an interest rate of 9% per annum, find the equivalent monthly rate first, and find the value 1 month after the final payment of €200 invested every month for 2 years in this bank. Okay, so Pause the video if you feel confident with this one. Try it for yourself. And here, they are priming us to do the change of rate straight away here, which is good. They are giving us an annual rate, but we want a monthly rate. So we must do what I cover in that very first financial maths video lesson on rates. I cover how to do this. Okay, so if you're not familiar with this, go take a look at that video and I go through it in a lot more detail. But for the rate change, I have like a little formula. I have 12 of these, of course, interest rates compounded over the lifetime of the year. The yearly rate is 1 plus I, and of course, I'm going to put in that interest rate there in decimal form. The reason this is 12 up here is because there are 12 months in that year. So I get 1 plus 0.09. Okay, so to get R on its own, I'll first of all do the 12th root of the 1.09. And then, of course, I'll subtract the 1. Take away the 1. And again, I'm getting the standard form. So I'm just going to add that 1 back on so I can see what that decimal is and just know that I'm taking that 1 away. So 0.007207323, which as a percentage is 0.72%. Now, I'm just going to use a more accurate version there, 0.7207. We go to 4 decimal places in the percentage, just because I'm aware that's the way they give it as an answer in the back of the book. But just, 0.2%. They haven't asked there what to round it to. It is always a good kind of rule of thumb to go more accurate than what you might think is required. So we'll do that here. We'll do the 0.7207%. So the decimal, then that's going to be 0.007207. Okay. Part 2. Find the final value 1 month after final payment of €200 invested every month for 2 years in the bank. So just to do that double check on the rate, you see we've got a monthly investment. A yearly time frame, that's an issue. But now, luckily, we have a monthly rate. So we do need that monthly rate to match in with the monthly installment. And now what I'm going to have to do is change that time frame to months as well. So 2 years, of course, is 24 months. Now I'm matching. So €200, we're going to add on the rate 0. Remember decimal form 0.07207 to the power of 1 plus, and the last, well, the very first payment technically will be 7207. That very first payment will be in the longest for the full 2 years, so to the power of 24. And get my formula written down and identify your A, your common ratio, R, and your N. So here's what we have, filling in that formula, and I'm going to put that into the calculator now. And I'm getting 5,257.29. So that's the final value after that investment. Okay, let's have a look at this question. So this is a bit different. This time we're being asked to find the sum of money, P, euros, that needs to be saved per month to cover the cost of a €1,500 holiday in 18 months' time. So the future value of the holiday is 1,500. Let's check our rates. Our rate is per month, and we have a monthly installment, and the time frame is in months. So we're matching in terms of rates and time frames. So that's good. But basically, we have the result of the future value, and we don't know what the monthly installment is. So the 1,500 is going to equal whatever I'm putting into the account each month, and then obviously adding on the 0.4% interest. So the first installment is going to be, we'll call it P. We're going to multiply, of course, and increase it by 0.4%. So it'll be 1 plus 0.004. power of 1. And of course, then the next second last, of course, that would be the last month. That would be the second last month, all the way up to the very first month that whatever that principal amount is, will have earned interest, and it would have been compounded 18 times. So to the power of 18. So this is my series basically, and I know my result. So what I want to figure out is what's P. So I'm still going to use my sum of a series formula, of course, and my A is P times 1.004. My common ratio is 1.004, and my N is 18. And so 1500 is equal to, put it in, of course, to my formula. And now I'm basically going to do all the number work on the calculator. I just won't obviously be able to put in the P. So get up the fraction button. I'm going to put 1.004 and then 1 minus 1.004 to the power of 18, close the outer bracket, and 1 minus 1.004. 04. Oh, careful always. Okay, 1 minus 1.004 on the bottom, and I'm getting 18.6997. I'm going to write that all down. Don't round too early in a question. So P times 18.69975507. And of course, to get P on its own, I'm going to divide both sides by that. And this then, 1500 divided by that answer, is 80.21 to 2 decimal places. Okay, here's a similar question. So why don't you pause the video here and see how you get on with it. So Anne received a check in the post for €6,523.33 after saving €8 at the start of each year for 5 years with her bank in a scheme offering 9% per annum. The first thing you are asked to do is write down a geometric series representing the value of her investment at the end of the 5th year. And the second thing you're asked to do then is find the value of A. So again, in this one, you're given the future value, and we don't know what the installment is. It's each year for 5 years with a yearly rate. So rate-wise, we are matching the time frame and the regularity of the installment and everything. So that's all good. So let's write out our series then. So that means that 6,523.33 has got to be equal to whatever this amount is, and that's going to be multiplied by 1 plus the decimal form of that rate, 0.09 to the power 1. And of course, then 0.09 to the power of 2, and all the way along to 1 plus 0.09 to the power of 5. Now, I guess there's only 5 amounts. You could write all of those 5 amounts to be sure that you're answering part I. You don't need to do the ... since you're only missing 2 there. So there we go. I've written all out for myself there. Okay, so I'm happy that I've answered part I with that. And now part II, find the value of A. So I'm going to use my sum formula, where A is that first term, or is the common ratio, and N is 5. And again, I'm going to do the number work on the calculator. I'm getting 6.52334565. And so we'll divide by that to get A on its own. And I'm getting 999.9993. So technically rounding that to 2 decimal places, it is €1,000.